We rewind the tape and we want to watch it back. And we watch it, and we watch it, and we watch it. But we let the tape continue to play past the point that we hit pause the first time. Right? So there's an area of tape on here that has never had the record button pressed for it. And so that just comes in as blank video or no time code. And then if we were to hit record again, camera just thinks that we're at the beginning of the tape and it starts over back at frame 1. What would be the problem with that?
Does it tape over?
It doesn't tape over it.
You don't want a blank spot in the movie or something.
You're just wasting the tape.
No. So actually at this point you would then have two places on a single tape with frame 1
It would be confusing.
going on. And yes, it would be confusing, not only for yourself, but more importantly, for your computer. So when you tell your computer to go to 10 seconds on this piece of, or on this tape, it's going to go, which 10 seconds? I see 2 10 seconds. And it doesn't know what to do. Either that or it's going to go to the 10 seconds that it's closest to. So it might be going to 10 seconds up here, and that's actually like 6 minutes into the tape versus the true 10 seconds, which is towards the beginning of the tape. Does that make sense? Right? Because again, the time code is how all of the electronic things talk to each other. And so you have to make sure that you do not have blank video on a tape. In order to not have blank video, you just need to make sure that you pause your video while you still see time code rattling off, and then hit record again. Because then the camera will recognize that there's time code that already exists, and then just start rattling off new time code based on what it already sees. Again, if it sees no time code, it just thinks that it's starting over and it starts back with frame 1. It's just a little heads up that can cause a lot of trouble. It causes a lot of trouble for the media center and people shooting on tape, because they try to import their stuff into the computer and it like freezes up. And
So that only happens on tape?
yeah, pretty much only happens on tape, because with these new little cameras that record to SD card, they just record individual movie files.
Are we going to use a camera with tape at all in this class?
Probably not. For this very reason. Like, recording continuous time code has just been such a pain for most people in the past that, you know, I've essentially started to move towards a tapeless system, which is all of our new stuff. All right? Okay, and so there are 2 different ways that a video camera or a display device will process a single frame of video, or process the frames of video. We've got interlaced and progressive video.
Are we going to have definitions for that?
Sort of, yes. Interlaced video, which is usually indicated by a little I. You'll notice sometimes you'll see like the frame rate, and then literally in parentheses or right next to it, you'll see an I. So like 60I is referring to 60 fields of interlaced video. And so what interlaced video means is that it essentially breaks up a single frame into what are called 2 different fields, an upper field and a lower field, that when combined create that one frame of video. Why would you ever need that?
Just to make it clear, more clear.
To make it more clear, kind of, yes, you're moving in the right direction. Ultimately, interlaced video was invented because the transmission lines needed for video couldn't handle all the data for a single frame, right? And so they actually had to break up even our standard definition stuff into 2 different fields that were going fast to fast, back to back, that would get combined on the other side into one frame. And so as a result, it's basically just due to the processing speeds of equipment, et cetera, et cetera. As processors have increased, right? So we've got like a lot faster computer processors that can handle more data now today than we did 5 years ago even. They can now do what's called progressive frame video and literally record all of the pixel information for one frame all at once. So it's like one picture, one frame. That's what progressive video is.
Wait.
So interlaced video, again, it's literally just due to the processing speed of our stuff. Like interlaced it's processing half of the picture.
Yeah, so it's two parts and then progressive video next one.
It's just one, right? And so it's like literally half the interlaced is half the pixel information twice as fast. But progressive frame video is all the pixel information all at once. And again, that was due literally to the amount of data that our little chips could process at any one point of time. As our processors have gotten faster, we can now move into progressive frame video for things like standard definition. However, you'll see high definition still be interlaced because that's 4 times as much data that has to be processed. And so, it's kind of like this tug of war between processor speed and resolution and amount of data and everything else. All right, so taking a look at the 2 different video standards that we use in this class. Again, we've got standard definition, which is literally indicated by SD. It uses a codec of NTSC DB. Codec is literally like the computer language used to both encode and decode all the little ones and zeros that your camera captures, right? So when the light hits the image sensors, it makes an electron which records pixel information in ones and zeros. A codec is literally how the camera or the computer reads and writes all of those little ones and zeros and turns them into pictures. Standard definition uses a codec of DV NTSC, and that has a resolution of 720 by 480, has an aspect ratio of 4:3, and records at a 29.97 FPS, or frames per second. Why 0.97? I don't know. That's just the way the scientists...
It's called 30 though, basically.
Yeah. It's close enough to 30 that that's just kind of what everyone refers to. Standard definition basically has 30 frames per second, or it's, again, real close, 29.97. And every few seconds you have what's called a drop frame. It like removes a frame. Okay. Standard definition video uses, in this class at least, it shoots onto these mini DV tapes. All right. And the cameras that we have, we've got 2 types of cameras that can shoot standard definition in our class, the Canon XL2 and these Panasonic cameras. All right.
You have to know like the main.
No. You just kind of have to be able to recognize them. In order to get standard definition video into your computer, you need a FireWire cable. Right? FireWire, you're going to notice, has 2 ends. It's got sort of like this U or horseshoe shaped end, and then it's got like this kind of squished little rectangle end. I'm going to pass this around. Let's take a look at those. This particular FireWire cable is called a FireWire 400 cable, and that will plug directly into your camera or into a recording device. And we've got a bunch of little videotape recorders kind of periodically, like there's one next to Victoria, one behind Melissa, I've got one right over here. And you can actually just play your mini DV tapes in there, plug that directly into the computer, and then your computer will capture using the FireWire. So standard definition, you have to have FireWire to get your stuff into the computer. High definition. These particular cameras record in a codec of AVC HD. I didn't write that up there. So AVC HD. And it has a resolution of 1920 by 1080. An aspect ratio of 16:9. And the frame rate is 60i, or they can also shoot at 24p. However, so again, what does the 60i refer to?
The interlace.
Interlaced. So that's 60 interlaced fields, or 30 frames per second, right? Because there's 2 fields for every frame. So when you see 60i, what frame rate is it? 30 frames per second. 24p is basically the digital world trying to replicate Hollywood-style film. Because when you shoot film, like 35mm film, they shoot at 24 frames per second. And so, you know, a lot of cameras now you'll see have an option to shoot at 24 frames per second. These particular cameras, if you're shooting progressive frame video, the maximum resolution you can get is 720. Right? So it's actually a smaller resolution, but it can record full, like one, or pixel for pixel, right? One picture, one frame. HD is recorded on your little SD cards. These are the cameras that we use, our SD100s. And to get high def footage into the computer, you need a USB cable. Right? This is a USB cable. Everyone know what a USB cable looks like?
No.
I would hope so. It's just like the long rectangular guy. And again, these can either plug directly into the camera, or we have little card readers, and so you can actually pop the card right out of the camera, plug it in here, and then plug it into the computer. It works just the same. It's pretty slick. Right? And so to get into the computer, just plug USB from camera or just card straight into the computer, and then you can capture. All right, so comparing standard definition to high definition. Obviously, standard definition has lower resolution than high definition, but this is a good idea. But high definition, because it's higher resolution, means that it's got a lot more data involved. So again, if space requirements on your hard drive are of any concern, you might want to choose to shoot standard def versus high def. Standard definition only shoots, or at least the DVM-TSC is all interlaced video. Our high def cameras allow us the option to shoot some progressive frame video if we want to. That ends up being kind of like beneficial for special effects, because when you're green screening interlaced video, a lot of times you'll get those fields separating and you won't get very clean edges. Standard definition, again, records to mini DV, which sucks because of your having to worry about time code. However, it's a very stable, archivable format. And it's cheap. These little tapes cost about $250 a piece, whereas an SD card costs like $40. Right? And so high def records to SD cards. You have to archive all of the stuff recorded to an SD card to a computer, right? So it can be a little bit more expensive. The nice part is that gives you independent clips. And then SD, maybe downfall, is that it's a real-time capture, meaning if you shoot 10 minutes of video, it's going to take 10 minutes to get it into your computer. Versus HD, if you shoot 10 minutes of video, it takes about 5 minutes to get it into your computer. It has a fast data transfer. And that about wraps it up. So those are some differences between standard definition video standards and high definition video standards. I hope you enjoyed this lesson. Stay tuned for more.